system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
Anyway, I'll clarify again. So this is a bar, right, which have certain loads. This is 63 kilonewton. The end section is 63 kilonewton. Even at this end section, this is 21 kilonewton, but that is compressive. Whereas the middle bar is at 49 kilonewton as well as 35 kilonewton. What question is telling is a bar having a cross sectional area 700 mm square. Area is 700 mm square. Is subjected to an axial load at a positions indicated. The value of stress in the segment QR. It is asking the stress in which section? QR. Which is QR? This is P, this is Q, this is R, this is S. So the question is asking what is the stress in QR section. So we have already learned, and I have already discussed the last time, whenever there is a questions given on principle of superpositions, wherever the loads are not same and not constant, what we do is we treat them individual. So I'll first take individually the loads. Right. Now what was the rule in superposition? The first rule over this is always go with the extreme parts, extreme sections. So what are the extreme sections for us? It is PQ, QR, RS. So which are the extreme sections over here? The extreme section, if you see, it is always on the first section and the third section. So if you go to the first section, you can see the first section is tensile, whereas the PQ section is tensile with how much load? With 63 kilonewton load. Whereas the last section, that is RS, is with a compressive force of 21 kilonewton. Correct? This is 63 kilonewton PQ section. RS section is 21 kilonewton. So if you see here, what you have to do is first section PQ. If one side is tensile, by default the other side will also be tensile. So keep as it is, 63 kilonewton. Now if you go to the last section RS, see the last section RS, the end section there is a compression of 21 kilonewton. So obviously the other side also will be compression with 21 kilonewton. Correct or not? Now this is what I have done. See, I haven't done much over here. PQ section was having a tensile force of 63 kilonewton. I have taken 63 kilonewton. Okay, this is tensile as it is. See, this was tensile. So I have made tensile. So if one side is tensile, so other side will also be tensile. Similarly, if you go to the section RS, here 21 is compressive. So 21 is compressive on one side. So obviously the other side will also be compressive with 21 kilonewton. Now as per that, what we are going to do now, we have to do 35 and 49 kilonewton. So how you can do is, before taking this 35 and 49, just see over this PQ. See the section PQ, how it is going. This is tensile. So we have to make, so from this border Q, from the other section, there will be what? Opposite reaction. Correct? This is a opposite reaction. How much? Same, 63 kilonewton. It is just like if I push you with 63 kilonewton, you will also try to resist. How much load? How much load I will be giving you? That is 63. So if PQ, if load given by PQ to QR is 63 kilonewton, then there will be resistance source by QR. How much? 63 kilonewton. That is opposite. That is equal and opposite direction. Newton's third law. Right? Similarly, here if you see, this is 21 kilonewton to RS. Again, equal and opposite. 21 is equal, but it should be opposite to this. So this is how much? 21 kilonewton. Now, I'm not writing kilonewton. You must understand this is because there is no space over here. It will be messy. That's why I'm avoiding writing kilonewton. Okay, but everything is in kilonewton. Now, after putting this, now go back to the question. See, section QR. This is section QR. If you take a point of section QR, what you get is here 35 kilonewton is there, which is going towards the center. See here, 35 kilonewton, it is going towards the center. So here also you keep it towards the center. How much? 35. Here again 49 is going away from the center. So take 49 away from the center. So if you see here, 63 is tensile, so I'll write it 63. 35 is compressive, I'll write minus 35. Here 21 is compressive, I'll write it minus 21. 49 is tensile, so I'll write it 49. So if I subtract this part out of 13, if I take it 5, I'm left with 8. From 5, 3 gone, 28 plus 28. Now here also 49 out of 9, if I take it 1, it will be 8. Out of 4, if I take it 2, it will be 2. So this is what? Plus 28 plus 28. You can see here, this is plus 28. So we can say that this is section QR plus 28. So it should be tensile. That is 28 and 28. Whereas this first sections are already been assigned. That is PQ is tensile 63, 63. Whereas RS, it is compressive with 21 kilonewton. Correct? So now we'll go back to the question. Question is asking what is the stress in section QR. So stress in QR will be what? Force by area. What is the force? Force is 28 kilonewton. And what is the area? Area is 700 mm square. 700 mm square. So when we put the value over here, what we get is, what we'll get over here is quite clear, that it is have to go with a megapascal, and here if I take further, what we are going to get is as simple as 40 megapascal, right? Mega is what? 10 to the power 6 Newton per meter square. So meter square, when you take out to mm square, it will be again 10 to the power minus 6, sorry, 10 to the power 6 mm square. So this get cancelled. So finally you will come across 40. So answer is 40 megapascal. Clear?
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.